So good afternoon, everyone. This presentation is going to be a little bit different in the sense that I'm going to be going over some of the ways in which the airborne and the UAV imagery can be accessed, and also going forward some of the ancillary data that are acquired, how those can also be downloaded from some of the platforms that we've put together. So there are two approaches to accessing the CABO data presently. One is a geospatial portal and the other is a secure Ftp. And I'd like to talk about sort of the benefits of both, because I think there is a natural way in which people might be drawn to just the portal, but I think there are still aspects of the FTP server that would be beneficial, especially when we're trying to download large volumes of data sets. So the geospatial portal, this is login by institution. So we've made individual logins for each institution. We can also provide anonymous and generic user download. So going forward, if we want to have the data sets sort of available to the general public or to others outside of CABO, we can do so without creating each person their own individual account. The way in which the data are downloaded here, however, is that you receive an email with a download link, and the data set that you chose is going to be zipped, and you download that through the email link. Contrarily, with the Secure Ftp, the login is individual. So this we can only provide to each user one at a time. There is no anonymous or generic user download available, and this is mainly due to these security settings that IT has set up at McGill in order to access this component of the server that lives in the basement of one of our buildings. There has to be certain levels of security. And the real benefit here, though, is that batch download is possible. So you can take all of the flight lines from a single day or from a single sensor and download those over the course of an evening without individually selecting flight lines. And at the moment, it's the Secure Ftp that allows access to also the non-imaging data, such as photographs, field notes, and other data sets that I will show you. So I'll show you a very quick video about the geospatial portal. We have created a much more detailed user guide as to how to do this, because there are certain steps we want to make sure that users get right so that there is no frustration in accessing this. So first of all, the user would authenticate based on the actual login information that is provided to the institution. And then you see in the catalog, we have the data sorted by year, by location, and then by sensor. So in this case, we're going to look at an example of the airborne CASI imagery for Ile-Gros-Bois, and we can add that to the map. Then we go to the actual map content. Once that circle stops spinning, it has loaded the thumb view. And it's important to note that you are not looking at the actual image itself. You are looking at pyramid layers. So you still need to actually download the data set itself. You can't really change band combinations other than the presets that we have defined here. And so for the CASI, we have a near infrared and an RGB preset that users can switch in between. And you can also load multiple lines at a time if you would like to do comparisons. So we'll also load an example from the SASE in this case. And so at the same time, when the CASI imagery, so the visible to near infrared were acquired, we also acquired the shortwave with a different sensor. In this case, those lines have one single preset. And you would repeat this process for all lines you would like to preview before you actually choose which ones you want to download. Now you can also download directly from here. So let's say we select this SASE line, you would type in your email address and you would click submit. And at that point, what happens is that you will get an email such as this that says that your request has been submitted to the server. A few minutes will pass and you will get your download link. Importantly, this is not a live email address, which means nobody is actually checking it. So you cannot reply to this email. It's only for sending you the actual download link for the individual files that you have chosen. If you go ahead and download that zip file, you will find in NB format the actual data set itself, as well as the associated header file. So we believe this is a useful way to preview the images before choosing which ones you want to download, But it is a slower process because you are waiting for the email and you are essentially downloading the lines one at a time. On the contrary, this is the interface for the Secure Ftp. So here each user has their own individual login information. And on the left would be your file structure on your local computer. On the right-hand side, that's the file structure on the server. And we have all of the data products ready for use in the final products folder, again, sorted by year, then by site, then by sensor. And then for CGOP, they're also sorted by plot. So that is the one that had different plots, and so it has an extra level of organization. If we look at an example within the Île-Gros-Bois folder to show you, we have the Twin Otter imagery. So Twin Otter is under POK. We have the UAV imagery, and then we have ancillary data. And within the ancillary data, we have the ground spectra of the panels or calibration tarps, depending on the site. There are photographs, which could be UAV photographs, UAV videos. They could be ground photographs, and those are all sorted by individual folders. We have the hemispherical photographs that were acquired during the time of image acquisition. And then we have the pyranometer data in the SPN1 folder for the time of acquisition as well, which gives the total and diffuse illumination during the time of image acquisition. For all of the data that is organized, we use the following convention of year, month, and day if you are looking for data sets from a particular day. Within the actual ASD, which is our ground spectra folder, you will have it sorted either by panels if it's for UAV data or tarps if it's for the aircraft. And within that, we have each of the process data sets for the 2% spectralon panel, the 50% spectralon panel, the 99% panel as a target, diffuse measurements of the 99% panel, and then the 18% FlexiSpec and the 20% PermaFlect, as well as the associated field notes. In order, if you're interested and you haven't seen this before, we have a description on how the field data were processed in order to make them comparable across day and across sensors. And the actual toolkit used for the processing is available for download. The link is here within the paper, but it's downloadable from Zenodo. It's a completely standalone, Windows only at the moment, that runs MATLAB in the background, but you don't need to have MATLAB installed to use the toolkit to process your own data or to understand all the steps that were taken to actually process the field spectra. Within the actual image folders, we have, in this case, what you have access to are L2G. So L2 stands for surface reflectance, so it's been atmospherically corrected, G being geo-corrected. And those of you that went to the workshop provided by Deep, he mentioned some of the benefits and drawbacks of working with a raster that is geo-corrected versus working with a point cloud. And so I will get to that distinction in a moment. Initially, we are finishing all of the raster processing. And so if you look within any of the subfolders, in this case, we're looking at an example of the CASI image from the Twin Otter that was acquired in 2018 at Île-Gros-Bois. You will find the files with the .dat extension are the data files and the associated header files. Really important that you grab both. So if you're going to grab line 11A from the CASI, you must also make sure that you download the associated header file. Otherwise, it won't open properly in any of the software. And just to draw your attention to the fact that some of these files are quite large. So this is the UAV data from Île-Gros-Bois. You notice that all the files are over 50 gigs in size. So that does require some consideration for how long it's going to take you to download, and also the computational resources required to work with those data sets. After some long deliberation about how we're going to provide the metadata, we decided to go with an extended NV header. And what you find is that there's a section here that with NV headers, we never modify. If we change this section here, it means that NV or our other software cannot properly open the information. There is a temporary summary in the description format. And the reason we say that this is temporary is because the moment you do something with this image, all of this will be replaced by the steps that you applied. So in order not to lose this information, what we did is we added extended header information at the end. And some of the important aspects is the reflectance scale factor, or the units. So in this case, if you are expecting a reflectance of 0.4, you will find pixel values of 4,000 because they have been scaled by the standard value of 10,000. We also have the raw pixel geometry. So in the across track resolution, the along track resolution, and the along track pixel spacing. So this is different than the resolution to which it's been geocorrected. And we also have the summation. And Catherine briefly mentioned this. It's always in the convention of across track pixels by along track by spectral. We will never sum the spectral pixels. We have not yet summed any along track pixels, so you only find various degrees of summation in the across track. And the last point I'd like to make is a difference here between pixel spacing and resolution. So in this case, we have pixel spacing is the distance between the centers of adjacent pixels. The resolution here is the full width half max of the point spread function, and Deep will talk about this in detail coming up. And that the across track direction is perpendicular to the direction of travel, and the along track is in the direction of travel. So visually, here's an example that Deep put together where the pixel spacing would be from the ends of the two arrows, that distance, and the resolution would be, in this case, the full width half max of the point spread function. So where we are in the actual processing, so we go from radiance that is non-geocorrected to reflectance that is non-geocorrected, which is then geocorrected and then cataloged in the Geospatial Portal. At that point, then the hyperspectral point cloud is generated, and that is then cataloged. So for 2018, it's basically the mere blue lines that are still outstanding, and Deep is currently working on the geocorrection of the new geocorrection of the CGOP lines. We actually reprocessed the entire suite of CABO data starting about a month ago, as there were some improvements in the geocorrections. We wanted to make sure all the data are up to date. And then we also have for 2019, we're making progress. We have the Ilgrove-Wakasi that is ready. The CGOP lines are ready. The hyperspectral point cloud is ready. It just needs to be cataloged, meaning that we need to finish the metadata for it. We also have the high specs, which just needs to be cataloged. The Montmégantic is a bit unique because it's the only data set we processed as a three-dimensional data set with the atmospheric correction, taking into account the topography. And so that the other ones were all considered as a flat atmospheric correction model. As soon as all of the data sets turn to green here, Deep will then start working on the actual point clouds, whether it's a flat point cloud or a three-dimensional point cloud, depending on the site, to have those available for all of the lines as well. Thank you. And we will be in touch with each institution and each person with the information about either their unique or their institutional login details, as well as some important details about how to log in and just some things to be careful for to make sure you're not locked out. For example, putting the password in wrong too many times and things like that.